Hello everyone, I am Praveen BR, Assistant Professor, Department of Electrical and Electronics Engineering, hereby teaching you microcontroller theory subject. Today we are learning module number 2 under microcontrollers 18EE52. The title of the module is Assembly Programming and Instruction Set in 8051. This video, you are going to learn only the instruction set of the data transfer function. So let us start with the data transfer instructions. So instruction set consists of mainly five things. One is the instructions related to data transfer, instruction related to arithmetic, instructions related to logical, instructions related to branch, and subroutine instructions with bit manipulation instruction. So what is an assembly language program? It is a language which is a low level language used to write the program in terms of mnemonics. The high level language, even though they are currently in demand, we prefer always uh, the low level language because of the applications. Because the assembly language program can be directly it can be used with the hardware. So direct hardware manipulations are there. Hence we prefer assembly language programming. One more advantage of assembly language programming is it utilizes less number of clock cycles and also it consumes less memory space compared to high level language. So coming to the instruction syntax, 8051 microcontroller programming consists of a syntax. Syntax is a general format. So what is a general format? It is opcode, destination, comma, source. So whenever I talk about opcode, opcode is the mnemonics what we are going to apply. So what do we mean by a mnemonic? A mnemonic is what the microcontroller can understand. It is a symbolic representation of the operation is called as an opcode. The short form of operational code is called as opcode. The assembler is used to convert the opcode to a unique binary code which the microcontroller only can understand, and that language is called as machine language. What is an operand? An operand is defined as the variables which we are using is called as an operand. So while an opcode specifies what operation it has to perform, operand specifies where to perform that operation, whether it is performed in the register, whether it is performed in the memory location, whether it is performed with respect to data. The source and the destination of the data is what we have calling it as an operand. In some cases, it could be data also. The operand will be either the address of the data or it could be data itself. So as I specified, the instruction set consists of 6 types. What are they? Data transfer instruction, arithmetic instruction, logical instruction, bit manipulation instruction, program branching instruction, and subroutine instructions. So let us study in this video only on data transfer instruction. So whenever I talk about data transfer instruction, it is dealing with only transferring the data from the source to the destination. We are not dealing with the varying the data. The data remains the same. Only thing is we are copying the data from one memory location to another memory location. So the general form of the data transfer instruction is opcode destination comma source, where the destination and the source can either be a register or it can be a memory location. Coming to the first data transfer instruction, that is move instruction. So whenever we are talking about a move instruction, and whenever I say move a comma rn, n indicates the registers that are there in 8051 microcontroller. We have totally 8 registers. So n can be from 0 to 7. So it can be R0 register R1 register, R2 register, R3 register, R4 register, R5 register, R6 or R7 register. So what does this instruction perform? This instruction is going to copy the content of the data that is present in the register and it copies it to the accumulator. Since registers are used in this purpose, the addressing mode is register addressing mode. So with the help of the registers, you are copying the data from the source register to destination register. Hence, we call it as the register addressing mode. Coming to the example, whenever I say move A comma R2, it copies the content of the register R2 into the accumulator. Let me say before performing the operation, the accumulator had 20 hexadecimal data and register R2 had 45H as the data. So whenever I execute R2, move A comma R2, it is going to perform 45H data that is present in R2 is moved to the accumulator 45H. Therefore, the data 45H is moved from register R2 to accumulator. Let us see one more instruction under data transfer, that is move A comma address. So it makes use of internal memory location addresses. So what does it do? It copies the content of the internal RAM address into the destination address. And since we are using over here the addresses, it is called direct addressing mode. Directly you are accessing the addresses, internal memory data addresses. Hence it is called as the direct addressing mode. Let me take an example. When I say move A comma 30H, the data that is present in the 30H is directly moved to the accumulator. So it copies the content of the data that is present in 30H into the accumulator. Let me say before executing the operation, the accumulator had 20H and the internal memory location 30H had data 45H. When I say move A comma 30H, the data present in 30H, that is 45H data, is moved to the accumulator. Let us see the next instruction, that is move A comma hash D8. Hash indicates it is data. D8 is the 8-bit data. So immediately you are moving the 8-bit data that you have mentioned in the instruction to the specified register. So here the register I am using is the accumulator. So immediately I am moving the 8-bit data to the accumulator. So it copies immediately the 8-bit data into the destination. So this type of addressing mode is called immediate addressing mode. So in my example, you can see when I say move A comma hash 45H, 45H data is directly moved from the destination, that is 45H itself is the 8-bit data which we are copying it into accumulator. The next set of instruction is move A comma at the rate of RP. P indicates that we can use only two registers. Which are the two registers? Only R0 and R1 can be used. R2 to R7 cannot be used for this set of instruction. So what does this particular instruction do? It copies the content of the internal RAM location pointed by the register into the accumulator. So let me say, I say move A comma at the rate of R0. R0 is the register which you are using, which is having a data inside the register R0. The data inside the register R0 is a memory location in the internal RAM. So it specifies the address of the memory location inside the internal RAM. So it copies the data of that internal RAM. It goes to that memory location 40H. The data present in 40H will be copied to the accumulator. This is what move a comma at the rate of rp will do. I'll repeat it. We never use any other register other than R0 and R1. Only R0 and R1 are the registers which are used here. So this is with respect to the internal data moves. So we are moving the data from a register to one more register, or it could be from an address to a register, or immediately the data is moved from the destination to the register. These are all happening within the microcontroller. If it is happening outside the microcontroller, then we call such instructions as external data moves. External data moves are related to, we are pointing out towards the external memory location. What do you mean by external memory location? External memory location is outside the microcontroller. I may be using the space outside the microcontroller. I'm pointing with respect to the external memory location. Who points it? It is data pointer who points to the external memory location. And data pointer is given by DPTR. DPTR is a data pointer which is a 16-bit register which always points towards the external memory location. So whenever I have an instruction which says move x a comma at the rate of DPTR, at indicates that it is an indirect addressing mode. The data that is pointed by the data pointer is the data which is present in the data pointer is external memory location data. You go to that external memory location, the data present in that external memory location, you copy it and you paste it in accumulator. So whenever I say move x a comma at the rate of DPTR, it copies the content of the external RAM address stored into the register DPTR, and then it stores it into the accumulator. So let me give you one example. When I say move x a comma at the rate of DPTR, your data pointer will be pointing towards memory location 8000. So it will go to 8000 H memory location. The data present in 8000 memory location is 45 H, which is copied to accumulator. So it is called indirect. It is called indirect addressing mode. In an indirect addressing mode, it is going to, the data pointer is going to specify the external memory location address. It goes to the external memory location address. It points towards the external memory location. The data present in the external memory location is copied to the accumulator. So this is what we call it as external data moves. Now, let us see what is code memory data moves. Code memory is with respect to program counter and data pointer. We are going to consider the data that is present in the data pointer and the data that is present in the accumulator. Both the data are going to be added, and that data which is added is going to specify the memory location. Such type of addressing mode is called index addressing mode. Let me say my data pointer is pointing towards 8000 H memory location. The data present in the accumulator is 20. So 8000 plus 20 is 8020. So your data pointer will be pointing towards 8020. So the data present in 8020 is 45H, which will be transferred to accumulator. So this type of instructions are called as code memory data moves. So we are taking help of 16-bit registers. What are the 16-bit register? Data pointer is a 16-bit register and program counter is a 16-bit register. So with the help of program counter and DPTR, we are going to perform the operation. So as I told you, here the program counter is pointing towards 5000 H memory location. So 5000 plus 20 is 5020. It goes to 5020 H memory location. The data present in 5020 is 45, which will be copied to accumulator. So this is what we call it as the external data moves. Now, in this data transfer instruction, what you have understood is you are moving from the source address to the destination address. So one of the data is not permanent. Now, what we do right now is we'll concentrate on data exchange instruction. What is data exchange instruction? Here, the data that is present in the source is moved to the destination. The data that is present in the destination will be moved to the source. Such instructions are called as data exchange instruction, and we use the opcode XCH. So what does XCH instruction perform? It exchanges the data between the two registers. It could be accumulator and general purpose register. It could be between accumulator and the address. It could be between accumulator and it could be between the specified data pointer, like that. So let us see the first one. XCHA, RN. The general purpose registers are R0 to R7, 8 general purpose registers we have. So it moves the content from the general purpose register to the accumulator and from the accumulator to the general purpose register. So whenever I say XCHA, R4, the data present in R4 is 45H. The data present in accumulator is 20H. When I execute XCHA, R4, the data present in R4 is moved to accumulator. The data present in accumulator is moved to R4. So they exchange the data between accumulator and R4 is called as data exchange instruction. Now let us see how to exchange the data between accumulator and the address. Here the address we are using is only internal RAM memory location address. So it exchanges the data between accumulator and the memory location. So whenever I say XCH A, 30H, what does it do? It is going to move the data from 30H memory location to the accumulator and from the accumulator to 30H. So it is bidirectional. The data is moved from accumulator to 30H and from 30H to accumulator. So that is bidirectional. Data transfer instructions are unidirectional and data exchange instructions are bidirectional. Let us move to the third one, which says XCH A, at the rate of RP. Whenever I specify P, it indicates that I can use only two registers. It is R0 and R1. So what does this instruction do? The register that you are specifying, it could be R0 or it could be R1. The data present in R0 will have the address of the internal RAM memory location. It goes to that internal RAM memory location. The data that is present in the internal RAM memory location will be copied and will be transferred to the accumulator, and the data present in the accumulator will be transferred to the data that you have specified in register R0 memory location. So here 20H is the data that is present in the accumulator. R0 is having 40H data. So 40H is the internal RAM memory location. It goes to 40H. The data present in 40H is 45H. So 45H and 20H are the two datas. So the data transfer happens between A and 40H. The data present in 40H will be transferred to accumulator and data present in the accumulator will be transferred to 40H memory location, and that is called XCH A, at the rate of RP. Coming to the last one, XCHD. D indicates that we are only transferring a part of the information. Whenever we are talking about an 8-bit data, there are totally 8 bits. 4 bits are the lower nibble and 4 bits are the higher nibble. If I am only exchanging the lower nibble keeping the upper nibble data as it is, then it is called as XCHD. Let me say I have XCHD A comma at the rate of R0. R0 is specifying 40H memory location. In 40H memory location, I have 75H. 7 is called as the higher nibble. 5 is called as the lower nibble. In accumulator, you have 62, where 6 is called the higher nibble, 2 is called the lower nibble. If I am exchanging 2 and 5 between accumulator and 40H, then we call this as XCHD instruction. So this is with respect to the exchange instruction. Coming to the stack pointer, stack is defined as the temporary memory location which is used in the microcontroller. Why do you use this temporary memory location? It is used to store any number of data for a shorter period of time. So to bring it from a particular memory location to the stack, we use push instruction. Push instruction is going to bring the data from a register to the stack. When I say stack, this instruction is used when the data has to be placed onto the stack. So stack is defined as a register. I call stack as a memory location. Which is going to store the information in a format called last in first out. Means the data which you are feeding last will pop out of the stack first, and to represent it we have what we call it as stack pointer. So a stack pointer is a register which always points towards the data that is present in the stack. So the stack pointer register gets incremented before the data is stored onto the stack, and then it stores the data. So let us see the push instruction. So whenever I'm talking about push 30H, the data that is present in the 30H memory location, it goes to 30H memory location. The data present in 30H is 45H. 45H will be moved to the stack. So before it goes to the stack, it is going to increment the stack pointer. If I say stack pointer is 07, it increments stack pointer to 08. It stores 45 in 08. So this is called push instruction. Coming to the last, that is pop instruction. So what is pop instruction? You remove the information from the stack is called pop. Retrieving the information from the stack is called pop instruction. So when you are popping the instruction, first you are going to remove the data, then you are going to decrement the stack pointer. So here, whenever I say an example called pop 30H, the data present in 30H is 20H. So it is going to, in the stack, you have an information 45H. What does it do? It is going to transfer the data to 30H memory location. Stack pointer is pointing towards 08H. It decrements to 07. So this is how you learn the data transfer instruction. So I am sure all of you might have understood the module 2. I have explained module 2 data transfer instructions. Thank you for watching this video.